We are going to use the Siemens TIA Portal software to program an SIMATIC S7-1200 and CPU1214CDC-DC PLC module with its kit is selected for the implementation of our project by using potentiometer whose various voltage level as an analog input and indicator lamp as a digital output. A PLC can only work with the values 0 and 1. For example, you can have a 0 to 10 volt analog signal. This signal can vary from 0 to 10 volts and have any voltage level in between. And since analog signals are continuous, this signal will always at any time represent a voltage level. The question is now, how does a PLC deal with all these different values? Let's say you have an analog signal at 5 volts going into the PLC. We cannot represent it with Boolean values, because they can only have the values 0 and 1. As mentioned before, a PLC can only work with the two values 0 and 1. But that does stop us from working with analog signals. Because what is really going on, is that the PLC works with binary numbers. This is due to the fact that a PLC or a microcontroller is really just advanced electrical circuits made out of transistors. Since a transistor can only be either on or off, these two states will then represent the values 0 and 1. When the analog input signal enters the PLC, it goes through an analog to digital converter. This is the component in the PLC analog input card that transforms the analog signal to digital signals. It is these digital signals that will eventually give our binary value representation in the PLC. Before getting to know about an analog to digital converter, it's important to understand what type of analog signal you're dealing with. In this article I will focus on voltage analog signals in the PLC programming. Let's begin with its program. As you can see, we need to create new project and give its name and select the specific PLC type among the existing alternatives. In these case it is SIMATIC S7-1200 whose CPU is CPU1214CDC-DC and shows its article number and version by looking at the PLC plate information, and then it's the completion of adding a device. Next to these, select program blocks and write the ladder diagram inside the main OB1. Here is an overview of an overall section of a trainee's kit. It includes power supply, that is DC 24 volt output. There are analog input pins having two channel whose specific names are channel 0 and channel 1, having analog address IW64 and IW66 respectively. Use the potentiometer as an analog input and comparator operations less or equal to and greater than. In doing so, we need to designate the voltage level we need to attain our intended value so you can get those representation. In general, the values read from an analog input are stored in a memory word. Sometimes you are required to convert these values to an appropriate format to use them in the program in order to do a correct decision according to the actual input voltage. The PLC is a programmable logic controller used to control industrial processes and machines. In the appendix section of PLC manual, so as you can see, 27648 is a decimal number designation of 10 volt DC. So to represent 5 volt DC we need to divide these number into 2, so we get 13,824, which is exactly 5 volt. While I'm used 13,800, which is a little bit lower than 5 volt, that means it is about 4.99 volt. From now on we have finished our ladder logic, so download the program into the PLC module by using LAN cable as a communication medium. Then monitoring the simulation and overall ongoing process on the serial monitor after the completion of its wiring. Let's have a look at the overall wiring technique. A positive 24-volt DC power supply is provided to the digital output of a PLC, and we can see the input voltage of a pot through voltmeter. Many people struggle with analog signals in PLC programming. The wiring and how to use an analog input or output in your PLC program can be tricky. Most often you will see digital example. So we need to provide this analog input to channel 0 pin, and the other terminal to 0-volt power supply. Here we are going to connect two digital output pin towards to indicator lamp 1 and indicator lamp 2 with their respective address Q0.0 and Q0.1. The indicator lamp along the column needs to complete the path to get on, so as to make this we need to connect its common terminal to 0 volts. As you can see, the indicator lamp 2 is turned on because its voltage is now 11, which is greater than 4.99 volt, and on the other hand, as you can see, when its voltage is in between 0 to 4.99 volt, only the first indicator lamp glow, and if it is above 4.99 volt, only the second indicator lamp glow. So in this scenario, as we tune the potentiometer and its resistance raise, that means the voltage across its terminals simultaneously raise. If these voltage is less than or equal to 4.99 volt, the first indicator lamp is going to be on, while on the other hand, if it is greater than 4.99 volt, the second indicator lamp turned on. From this latter logic, the two indicator lamps are connected to the digital outputs of the coil tag and can't glow at the same time. As you tune the pot, it switches for those two different indications. When choosing the type of input or output module for your PLC system, it is very important to have a solid understanding of syncing and sourcing concepts. In order for a PLC I/O circuit to operate, current must enter at one terminal and exit at another. This means at least 2 terminals are associated with every I/O point. The input or output terminal is the main path for the current. One additional terminal must provide the return path to the power supply. Together, the main path and the return path create a loop, or a complete circuit for current to flow. We are using sourcing inputs mechanism. A potentiometer is a passive device that provides an adjustable electrical resistance 3-terminal resistor with a sliding or rotating contact that forms an adjustable voltage divider. If only 2 terminals are used, one end and the wiper, it acts as a variable resistor or rheostat. The measuring instrument called a potentiometer is essentially a voltage divider used for measuring electric potential, voltage, and it is a simple mechanical device that provides a varying amount of resistance when its shaft is turned. By passing voltage through a potentiometer and into an analog input on your board, it is possible to measure the amount of resistance produced by a potentiometer, or pot for short, as an analog value. An analog input converts a voltage level into a digital value that can be stored and processed in a computer. Thank you very much, and don't forget to subscribe and share the video if you find helpful. Stay creative. This is PRD-SS channel.